Absolutely stoked. That's how the FusedVR team feels about ARKit, which lets you tie together Unity and the augmented reality capabilities of an iPhone so that you can create awesome AR applications. My name is Hassan, and today I'm going to be showing you how to build a painting prototype with ARKit. This prototype is inspired by a Unity test project that was released recently by the Unity team. So you can actually find a more fleshed out example. I'll show you where that is later. But today I'm going to show you a demo, and then we'll jump into building a basic version of this AR painter from scratch. Let's get to it. Starters, go to Google and search for ARKit Unity. On the Unity forums, you'll find this post about ARKit support inside of Unity. This will walk you through all of the features and, more importantly, all of the requirements that you'll need if you want to use ARKit with the Unity platform. The key things to keep in mind are that you need a patch version of Unity. You'll obviously need access to the Apple build stack. You'll need iOS 11 or later. That's an important point because right now you can only get iOS 11 with a paid developer account. So keep that in mind if you actually want to build what we're going to be developing today to an iPhone. You'll also need a beta of Xcode 9 and an iOS device that supports ARKit. So that's an iPhone 6s or later. I also recommend reading through the rest of this to make sure you have everything you need, and you'll also want to download this Unity package. If you want to do some extra credit, I also recommend checking out the WWDC video on when ARKit was introduced. It's a great way to understand all of the capabilities that we'll have at our fingertips, and you'll have a lot more context when it comes into ARKit development. So, review all of this, download everything you need, and we'll dive right in. To start building, open up your Unity project, and the first thing that you'll want to do is import that package of the Unity ARKit. So find wherever it is and import that. You'll see that I've already done that, and I've done some basic scene configuration that I'll walk through now. First of all, we're going to want to use the main camera that comes with our scene. So zero it out, set the clear flags to depth only, and you'll also want to add the Unity AR video script that comes in the ARKit plugin. You can find it in Plugins and iOS inside of Unity ARKit. So add that to your main camera, and you'll also want to create a new game object called an AR Camera Manager. You could really name it whatever you want, but on it you want to add the Unity AR Camera Manager script, and for the camera field, drag your main camera over to there. Now at a high level, what these are doing are firing off an ARKit session and also updating our camera every frame, so that it's not only detecting features in the environment for us to track, but also updating what's on the screen. So those are the only changes that we need to make there, but what we want to now start doing is building out the framework for the painter that we're going to be using. So we're going to use a UI canvas. And on that, I'm going to add an empty game object. I'll call this the paint manager. And there, I'm going to add in a script that I've already started to configure that I'll walk through too. This is called the Paint Manager script. So here, what we're going to do at first is just get this to work by tracking our camera position and painting a cube or some sort of object wherever the camera is moving in the scene. So first off, what we want to do is use the onEnable and onDestroy functions to subscribe to or unsubscribe from the AR frame updated event. So you can copy these lines over into your script. You're also going to need to determine what happens when we subscribe to and listen to this event. So I have this AR frame updated, and what's going on here is that whenever we update the AR frame, so when we detect a new frame using ARKit, we want to track the position of our camera, and that's what's going on here. We're using this getCameraPosition function that I created right here to convert the camera's position from AR coordinates to Unity coordinates. So you can just copy this over. And the reason why we are adding this camera.main.transform.forward times 2f is we want to make the position that we paint not exactly where the camera is, but a little bit in front of it. And what we're doing inside of this if statement is simply checking, is the current position of the camera at least, this is 1 inch actually, at least 1 inch away from our previous position, because we don't want to keep painting in the same place. We only want to paint as we move. So what we need to add in here is actually, let's instantiate an object when we have moved at least an inch over and when we're detecting these new frames. So we're going to use instantiate, but we also need to configure what we'll be instantiating. So I'll create a game object. We'll just call this cube object, and we'll instantiate that. We'll do it at paint position, and we can use the whatever this transform's rotation is. So that's that. We just need to configure it in our scene. So let's wait until this loads, and we'll need to create a prefab that we can plug into this. So I'll create a cube, going to scale it down. And if I drag this over into assets, it automatically gets made into a prefab. And that's what we'll use for our paint manager. So let's go ahead and build this. So go to build settings, make sure that your platform is iOS. And the only thing that we need to change is some small bug inside of the player settings. There's a field that says, I think it's AR camera usage. We'll see it once we switch the platform. But if we don't change that, for whatever reason, Xcode crashes when we try to deploy. So that's just an example of a bug that needs to be worked on in later versions of the ARKit package. So I'll go ahead and wait for this platform to switch, and then I'll show that. Looks like we're set. We go over to this, in the player settings, go into other settings, and in camera usage description, that's where we can type in any string we want and it'll work. So AR camera, and then let's hit build. Inside of AR TiltBrush, I'm going to make a new folder. Let's call this my builds folder, and that's where I'm going to select to build this. I'll save it as AR tilt demo. So go ahead and let that build. Once the project has finally built, we just need to open it up in Xcode to deploy. So plug in your iPhone to your computer, open up Xcode, and find that build folder that we created. Let's open that up, and the changes here are minimal. Go to this part of Xcode, and we just need to select a team. So that's my name. It'll be something different for you. And make sure that you have this configured Unity iPhone, and whatever phone you have that's plugged in, hit build, and then we'll be able to see our demo. So as you saw from that demo, if you move the camera around, you're getting cubes. Now, it looked imperfect, but that's fine because that's not the final demo we're going to be using. I just wanted to show you one build cycle. The first thing that we need to do is get rid of our directional light, and then next up, we'll be adding the buttons that we'll use for our paint application. So let's add 3 buttons. And we'll add one first and configure this to the right width and height that we want. So I found that 200 by 100 works pretty well. We're going to want a button in the bottom left, the bottom middle, and the bottom right. So let's just duplicate this button. You can hit Command D to do that. One of them is going to be a paint toggle, one will be a reset button, and the other will randomize the color that we're using to paint. Later on, you could make this more sophisticated if you want to. So let's go ahead and position these. First of all, the paint toggle. We'll put that in the bottom left, so click over here on the anchor presets and hit bottom left. Then we can change the position to make this go to that corner. And let's change the anchor to 0 so that it's anchored in the bottom left, or sorry, the pivot to 0. And we also want the Y to be over there. So now when I put it at 0, 0, you see that the pivot point is right there. And let's actually nudge this over just a bit. So 50, we'll nudge it over 30 and 30 up. Then we'll call this paint toggle. Now let's put our reset button in the bottom right. So hit the anchor presets, go to bottom right, hit 0, 0. And here we can also set the pivots to 0. And now we're going to want to go -30, or actually we should go 1, so that's on the right. Then we can go -30 to push it 30 away from the border, and 30 up works just fine. Let's call this reset. Then the last one is this randomize button. So this one should be the easiest. Just move it to have the bottom middle. Then the pivot for this should be 0, and we can set 30 to make it in the middle. We'll call this randomized. And the last thing that we need to do is link these up to the script behaviors that we want to run when they're pressed. So for every button, you can see that it has this on click. And when we hit plus, we can drag in another game object so that we decide what we want to run when this thing gets clicked. So we're going to drag over the paint manager, and we're going to do that for all of these. So when this gets clicked, we can run a function from the paint manager. Now I want to open up the paint manager object, and on that, remember, I have the paint manager script. Now I've already added in these different functions that are just stubbed out versions of what we're actually going to do. So when we hit the toggle paint button, we'll hit in the console toggle randomize when we hit the randomize color, and reset when we hit that button. So let's go back here. And on those, if we scroll to Paint Manager, which is a script on the Paint Manager object, we can run the toggle paint function. Then for reset, same thing, but let's select the reset function. And same thing for randomize, but the randomize function. Now the good thing about this is that you can actually test this in the editor. When we hit play, we'll go to our game view. We can go to our console. And we can see that when I hit toggle, toggle's printing. I can see randomize and reset. So make sure you have this all set, and in the next section, we're going to actually get some painting started. Before we jump into the code again, I want to revisit that Unity post that I originally showed. What's cool about this post is that a bunch of people have been building different ARKit examples, and one of the examples from Unity actually was a painting example, so we're going to be riffing on that and building a more simplified version. That's how we're going to approach creating the code for our paint behavior. The overall approach is that we are going to be using a bunch of particle systems. When we select one color, we're going to create a particle system where we paint particles of that color. When we're done with that color, we're going to save that particle system into a list of particle systems, and we'll create a new particle system for the color that we're moving to. As we keep doing this, we're just going to get a list of different color systems of particles, and the reset button is just going to delete all of those. So let's jump right in and start stubbing out some of this code. The first thing that you'll notice is I've added some new global variables into the paint manager. So new paint vertices is something that we're going to use to detect if the camera has moved and if we need to paint new paint points. Painting on is just going to keep track of if we're in painting mode or not. We also want to keep track of what color we're using. Previous position we had before. Particle system list is going to store all of our different color particle systems. Curve vertices tracks the phone's position so we know where to put the particles. And then particle system PS is just the current particle system that we're using. So let's start stubbing out the start function first. The first thing that we need to do is actually set a lot of these variables. So painting on should be false at first. New paint vertices, that's also false. Paint, what did I call it again? Particle system list. We need to instantiate all of these lists that we have. So that's a new list of type particle system. And we also need to instantiate our first particle system. One thing that I did not note is that we're going to be using the same template particle system, which I added up here as a public variable so we can link it in the inspector. And we need to instantiate a new particle system every time we want to use a different color. So the other thing that we need to do is instantiate the current vertices list. So there's a lot to do in this start function. This is a list of vector 3s. And we also want to set the color to whatever our default color will be. I'll use green since that's our FusedVR color. And you could even specify the RGB if you want. So now we can stub out the different functions. So toggle paint is pretty simple. We just change painting on to whatever its opposite is. Then randomize color is also simple. You can just do random.color. And reset is where it starts to get a little bit more tricky. So we'll do this one first, and then we're going to jump into update, which probably has the most nitty-gritty code. So in reset, what we need to do is, first of all, destroy all of our particle systems that are stored in that particle system list. So particle system, we'll just call them P in particle system list. Destroy all of those. Then we can recreate that list. Then we also want to destroy whatever the current particle system is in case we haven't added it to that list, and instantiate a new one. We also need to reinstantiate the list of vertices. Oh man, getting used to the Mac is not going very easily. So that's everything for reset. In randomize, there's actually one more thing that we need to add. So if the current particle system is non-empty, like when we click to randomize the color, we want to end the current particle system and start a new one. So we need to check if particle system.particle count, so basically if there are particles, what we need to do is save that particle system. So I'll call save particle system method, and then we can do our change of paint color. So let's create a method for that. I'll put it down here. And what we want to do here is add the current particle system to our particle system list. Then create a new particle system. And see if there's anything else. Oh, also reset the current vertices. Okay, so that's everything for these stub methods. Now we need to talk about how update is going to work. So what update's going to do is it's going to check if paint is on and if there are new vertices or new camera positions to paint. So we need to update the way that this AR frame updated works just a little bit. So we didn't complete it before, but if painting is on, we want to be tracking the positions that our camera is at. So we're going to use curve vertices and add the paint position. So we can do that all on one line. And we also want to set new paint vertices equal to true. So an update now, if painting's on and we have new paint vertices, then we actually need to draw some new particles. So here we have if curve vertices count is greater than 0. Then what we'll do here, we need to create a list of particles. Call this particles. Then next up, we need to iterate over all of those current vertices, and for each vertice, make a particle to represent that vertex. So index 0 for each. What we want to do here, set so now we're iterating over this list of vertices again, and for each one creating a particle to represent it. Next dot, we need to decide the size. I believe that the size I used was, let's see, I used 0.1f, and you can configure that however you want. It really just depends on how big you want these particles to be. And if you want to flesh this out even more, what would be cool is to make custom sizes for the different paint brushes. Like that would be one awesome thing to do. So once we've done that, basically created a particle for every vertex, then we need to set what the particles are on this particle system. So we pass in particles, and we also tell it what the size is. So it's just the size of our current vertices, because those are what we painted. Then we set new paint vertices equal to false. So this was a lot of stuff. I'm looking at my notes here. I think we caught everything, but let's go ahead and give this a try. Alright, I realized that there are 2 more points to add. So first we need to create that particle system that is going to serve as our template for all of the colors that we paint. So we'll call this template system. Let's just zero out everything on it. And we also want to turn off play on awake as well as emission and shape. This particle system is not actually going to be emitting anything. Instead, we're going to be constantly overriding its particle set. So once we've done that, that's actually everything we need for our template system. So drag it into the assets panel to create a prefab. You can delete that from your scene. And then on your paint manager, be sure to link up that template system with the field for the game object we're using when we instantiate a new particle system. The other thing I noticed is that there was a bug where we instantiate the particles inside of update. We need to tell this list how big the list is, so just pass in curveVertices.count. So once this is done, head over to Unity, build it, and let's run it on Xcode to see it in action. There you have it. a working prototype of a painting application in just around 20 minutes. You'll notice that in that demo, I changed the click color of these buttons to be red so that you could see when I hit the different buttons. We hope you enjoyed this tutorial, and a huge shout out goes to all of you for following along, as well as the Unity and Apple teams that worked on getting Unity integrated with ARKit. We're stoked to keep building for it. Definitely consider leaving a like, comment, questions, or a subscription to our channel if you haven't, and we hope to catch you next time. Until then, as always, happy building.